okay. We're doing some coding stuff, and I'm going to be flipping between windows, so I kind of want both my hands, and I don't want to hold the mic if I don't have to. Let me wake this thing up. Check the input terminal.
Oh, sorry, we have to actually just do the push button.
Sure. Okay, so the title of this presentation, if I pull it up, to the beginning. There we go. So I was struggling to come up with a good title for this. I decided to go deceptively simple, but hopefully there's more to it than just how to write a unit test, or at least I'm hoping to convince you there's more to it than just how to write a unit test. The theme of this, I think, is that you can tell a lot about a system by its test suite. And what I'm going to pose is that really unit tests are sort of a forcing function for good software design. And if you can write an elegant, concise, and also correct unit test, then it's usually a reflection of the fact that the code that it's testing is elegant and concise. And as I'm about to tell you, there's nothing I love more than elegant code. So a little bit about me. I'm an architect, as you just heard. I'm an architect with the TurboTax group at Intuit in San Diego. I'm actually a San Diego, born and raised San Diegan. I went to UCSD where I got my bachelor's in computer science. Went to Mount Carmel High School in Rancho Paines, just at the freeway. Spent my entire life here. And I guess I haven't left yet, so I have to kind of reason to. The current work that I'm doing with Rahul, actually, who's on my team, and Harrison, who's on my team, and Jatinder, who's on my team, thank you for coming out, is we're building real-time intelligent personalization systems that will power the next generation of TurboTax products. I'm not going to be talking about that today, but if you want to hear or learn a little bit more about it, you can talk to any one of us. We'd be happy to fill you in. And then on the softer side, I love long walks through elegant code and to cuddle up with a good book on effective software design next to a warm rack of servers handling thousands of concurrent transactions per second. So I'm going to get together for a drink after this. Hopefully you have a similar interest. Okay. So first I'm just going to present a program by way, or I should say I'm going to present a set of requirements by way of a program. I came up with the simplest thing I could think of that was only a few lines of code, but was still interesting enough to spend a few hours talking about. And so here's a program. We'll be diving into the actual working version of this in a second. I've called this program Untestable. So Java -jar untestable.jar will prompt me or the user for a username, a password. It will ask me whether or not they want to remember that password, and then it's going to call a Bitbucket API for dumping my user profile. So this is my Bitbucket user profile. And it does a few other things as well, but I'm just sort of setting the scene for a very simple program. So how hard could this be to write? Well, the naive, untestable implementation is extremely easy to write. It's something that I've called untestable. It has a static main method, and it uses, in a tightly coupled way, the console to put and get input, the file system to remember my credentials, and it uses I've called it Bitbucket, but what I guess I mean is the Bitbucket REST APIs to pull information down from the Bitbucket servers. And so then what I'm going to be doing, I guess, is walking us from the untestable implementation to something that is much more testable, probably really pushing the boundaries of unreasonably testable. I wouldn't argue that for this particular implementation you'd ever spend as much time as I did making it as testable as I did. But this is, again, meant to be sort of a use case in testability, software design, et cetera. And so if this is the untestable implementation, which is extremely simple, then this is the testable one. And hopefully we'll get there by the end of this. And we'll see all the crazy things that we do just to make something testable. And again, maybe I wouldn't really advocate for this if something is really simple and you just need something that's going to pull your Bitbucket profile and you want to spend 10 minutes doing it, then by all means do this one. But don't think that you're going to be able to test it or manage it over any long period of time, or let it evolve as the requirements around the program evolve, or anything else that you're going to need to want to do in any kind of real environment where somebody's going to be paying you for the work. And so that's sort of it for the slides. I sort of said in the abstract for this that it'd be a lot of coding, or at least walking through code. So I'm going to jump from here into Bitbucket and into IntelliJ, where I've got something running. So the first thing I want to do is just sort of give you guys a feel for what this program does. Can everybody read that? Maybe? I know it's towards the bottom of the screen, unfortunately, but if I clear the input and move the cursor to the top. Okay, so here's me running the command. I guess I've already saved my credentials, so in this version it's actually just echoing back out the result of this service. But if I remove .untestable and call the service again, this time it's prompting me for it. So we got a bug there. It's going to ask me for my password, which you're not going to be able to see because I've turned echoing off. It's going to ask me if I want to remember it. This time I'll say yes. Oops. I think I stuck it in there incorrectly. Shouldn't have chosen such a complicated one. There we go. So now it's echoing out the input. If I call it again, it shouldn't prompt me. It should just echo out the profile. It also offers another command called, this one will dump my profiles. User repo, sorry. Is that the one? There we go. So now it's calling a different API, but it's remembering my credentials from the last call, and so it's spitting out this. And so as you might imagine, this is incredibly simple. And so what I've done, if you guys are interested and want to follow up on this afterwards, this is all up on Bitbucket in a repo. And what I've essentially done is documented the journey from untestable to testable in a series of tagged commits. And so what we've just seen is the initial state. And so here's the initial state. But the problem with this is that it is, as I've said, untestable. And what I mean by untestable is that it is literally impossible to write a working unit test for this program. So let's go see if we can figure out why. Git tag. Check out. So I'm going to check out. I've got tags here that mark every evolutionary milestone. I'm going to check out the initial state with a space in the right spot. So now I'm at the so this is the source code of the program. So what you can see is that I've got a static main method, and it's just receiving arguments from the command line, and then it's doing it's breaking every cardinal rule I could think to break in terms of writing a program. So everything is static. It accesses the console in a static way. It directly uses the console to read the line, read the password, which means it's turning echoing off so that my password isn't reflected on the command line. The file path is sort of hard-coded here at the top. It's directly using a relatively sort of low-level interface for interacting with a HTTP client and a REST service. And then it's printing out the output using system.out.print. So if I were to try to write a unit test for this, which I can get to, Untestable Test. So this test will error out because there's no console available to the JVM, and the JVM is not started via the console. And so since we've got the JUnit runner starting this thing, there is no console. So the very first thing that goes wrong is this line of code right here. The very first time I try to say c.readline, I get a null pointer exception because this is null. And not only that, but I have no way of injecting another version, a mocked out version, any kind of version of the console in here. So I just get a lot of failures. And so if I run command, so if I do maven clean install, and I don't turn off the test, I get a build failure. This actually is the compiler. All right, well, I'm not going to spend time figuring that out. In some other version of this that I tested before I got here, this test didn't run for the reason that I was just saying. So how do we, what do we do from here, I guess, is the next question. And this brings about a quick aside on what a unit test is really supposed to look like. So a unit test, or any kind of test, really, well, no, a unit test, is represented up here by this box at the top. A unit test invokes some behavior of the component that is under test. And if this component, and they typically do, require other things in order to provide its functionality, the idea is that the unit test in part of its setup is responsible for creating or controlling the dependencies by mocking them out. So the first thing that, or the thing that makes this possible to do is this notion of like coding to an interface. So if instead of coding directly against system.out.console or system.out.console or system.println, I'm sorry, system.out, I was coding to an interface that did some of these things for me, I'd be in a much better position to be able to mock this stuff out and make some kind of progress. So let's see, what did we do in here? So in this tag, which is a commit that sort of evolves the system a little bit, so let me check that out. So that one. You can kind of tell by the tag name, but here we're going to be live demos, right? I think I deleted a semicolon back. There we go. So in this version, you can kind of tell by the commit message here. But what I'm going to attempt to do is decouple the application from the console for the input-output functionality. So the application, in this version of the application, it now reads and writes to buffered readers and print streams rather than the native console or some of the other sort of low-level implementations. Additionally, so that we give ourselves the opportunity to inject something in it before our test starts, I've implemented this sort of pseudo-singleton pattern. So we've got one thing that we'll note here is that instead of reading and writing to console, I'm reading and writing to a buffered reader, which I have the opportunity in my test setup to switch out the underlying implementation for. You'll note here as well, compare, it's actually probably easier to do it this way. Compare with. All right, so here's the difference between these two files. So previously I was just using the console sort of natively. And now I've broken so I was using console for input and output. Now I've broken those two things up into a component that's used for input and a separate component that's used for output. And I've implemented this sort of pseudo-singleton pattern so that I only create a real buffered reader if I've got no other option. And the only reason I would have no other option is because I'm running in a real way. If I'm running in a unit test kind of mode, then my unit test will have gone to the effort of switching this out before this line of code runs so that I've got a fake version of these things set up. The other thing, but you'll notice that there's sort of a drawback to this. One is that when I was programming against the native interfaces over here, I could both output and get input in one sort of more elegant line of code. I could say c.readline, I could pass the username, and this function will print the username out and then wait for B to type something and hit the carriage return in the new line, at which point I get the username back. But since we've had to sort of change interfaces and pop up to a higher sort of more abstract level, I don't have the ability to be quite as expressive anymore. I have to break up my functionality in a way that makes the code a little bit less clear. So that's one thing that you should note and we'll be fixing later on. What else?
Are you also hiding masking a password?
I'm sorry?
You're not masking a password.
Yeah, another good point. I've actually broken a requirement here because using the console, and this is why I'm not going to run it and like actually demonstrate this because you can see my password echoed. So you'll note over here that we did something like, it's somewhere out here, I'm collecting the password. Yeah, right here. So there's a function called on the console called read password, which is maybe more appropriately called read sensitive piece of information that you don't want echoed out to the display. But if you go click into the source code of this, you see that it does some tricky things to turn echoing off on the console so that while you're typing, nothing's being displayed. And then as soon as you're done, it turns echoing back on. We get the benefit of being able to write at least one unit test that can work. So let's go look at that unit test. So here's Untestable Test. So this thing, hopefully if I type maybe install, will actually work. So what I do here is I create an input string that mimics user input. I create a buffered reader by initializing the byte array input stream to initialize the input stream reader, to initialize the buffered reader, and I set it to the static variable that I have access to. And now I'm able to give it a value before that null check hits, so that we don't end up creating a real version of it. And now I can actually call a command, and it does something interesting. I'm able to get what was printed by revisiting my output stream and getting it to flush itself first, and then I get the string back. And then I get the raw string of output, and I can compare it to whatever I expected. So by the sort of most raw definition of a unit test, I suppose this kind of works. The other problems with this, though, is that I haven't mocked anything else out. So I still need to call a real REST service, which means if I'm running this on like the Jenkins build server in some lockdown portion of my network, now I have to make sure that I've got a proxy out to the internet so that this actually works. The other thing is that nobody in their right mind is going to want to put their real username or real account in here. So the only test case that I can test is the one where Bitbucket says, sorry, this isn't a valid password. Because that's the only way I'm going to be able to provide a jump. So let's run this one. Maybe. Let's see if this actually works. So the last one didn't work because of the command line. All right, well, I'm not going to debug this one. Okay, I'm not going to spend the time to debug this, sorry. But this, in some other version of this, it actually works. But only barely, only sort of by the most minimal definition of a working unit test. So let's sort of highlight what we did and what we're going to be doing next. Let's see. So yeah, the ability to collect information from the user has now become, so this is the general pattern for unit tests. Yeah, so we've, the problem is that, as I was stating, the ability to collect information from the user is a little bit more muddled. In the other implementation we could call readline, passing in a string value at the same time that we were expecting to collect the value back. But in this implementation, it's been broken up into two different function calls. So if you're looking at the code, it doesn't look maybe quite as obvious what's going on. The other issue someone pointed out is that we've actually broken something because the console is actually does not have echoing turned off. So anybody who's typing their password would have it reflected out on the command line. So this is where we're going to move on to the sort of next phase, where I propose that we, instead of living with the interfaces that we don't want, we create the interfaces that we do. And we use the things that are already doing all the work for us, like Java console. We hide it behind the interface and just let it do its thing as we look to implement these custom interfaces. I've also sort of changed the words a little bit to reflect more accurately, or I should say I've changed the words of the functions a little bit to more accurately reflect what it is that we're trying to do. We're actually trying to collect information from the user. So a more expressive name for this sort of more purpose-built interface and method might be something like collect. But really, if you were to compare the argument or the format of the signature of this method to the signature of the console read method that we were using previously, it's exactly the same, except the name has been changed. I've also introduced something called collect sensitive. So collect sensitive is analogous to read password, but naming it something like collect sensitive maybe just through its name kind of indicates that it might be used for collecting anything that is generally sensitive, not necessarily something that is a password. And so interface design, we could have an almost whole other topic on how to design a good interface. So what I'm trying to do is sort of touch on some of these aspects, but by no means perfect them in this talk. But I'll pause here for a moment just to talk a little bit about how all of these things sort of become obvious, even if all you're doing is looking at this from the perspective of a unit test. For that reason, unit tests are a pretty powerful mechanism for enforcing good design, appropriate interface design, and all the other things that you want in readable, testable code. So moving on, the other thing we have is display, which is just displaying information to the user with no intention of collecting anything back. And so we can achieve exactly the behavior we need and do so in a clear and expressive way, much more so than if we were relying on the interfaces that were natively available to us. Let me check out that code. One of these days, I'm going to run Maven install. It's going to do what I think it should. Maybe you guys will be here when that happens. Git checkout. Okay, so let's read the commit message a little bit. And let's see what it's doing. So here we are attempting to decouple the application from the console for I/O. Sorry, that was the old one. The new one is this one. So we added a custom interface called user I/O. So let's go look at that. And you can see that the project structure here is starting to evolve a little bit. Before I just had Untestable Test and Untestable. Now I've introduced something here called user I/O, which is, now I have the snippet in the Bitbucket account, but this has the full sort of documentation, which I always advocate for, by the way, especially when designing an interface. But this sort of more fully explains everything we just talked about. It's an interface for collecting information and or displaying it back to the user. And here, we can now bury our hard to test code, but presumably, it's so easy to write that the argument for unit testing is a little bit diminished and isn't nearly as tightly coupled to the business logic of our application, which we are much, much more interested in testing and getting some level of confidence about. And so here's where my implementation of string, of collect, is just to turn around and use the console's readline method. My implementation of collect sensitive is just to turn around and call the console's read password method. And now I don't have to reinvent how am I going to turn off echoing on the console. Not that it would be difficult because I could peek into the source code and see how they did it. But it's not something I want to be in the business of doing if I don't have to, certainly. And my implementation of display is to use the console print line method, which will print everything back out. And let's see. What other points did I want to make? So here's a modified sketch of the system's key components, and we'll kind of get a sense of what direction the system is starting to head. Hopefully we've justified everything that we've changed along the way, but we've already added a few more boxes and lines, but done so for good reason. So we still have our untestable application here at the top. But here, instead of using, previously, this line would have been drawn directly to the console. Untestable uses the interface, and Untestable creates an instance of the console, which implements this interface. And then the console is the thing that actually uses console I/O is the thing that actually uses the underlying console. We haven't addressed similar problems with these other components yet, but what I'm going to be doing here over the next couple of commit messages anyway, is diving more deeply into how we're going to solve this vertical in our stack. And then what we'll do is we'll come back and apply those patterns everywhere else, because they'll be the same patterns. And so the unit test is now quite a bit easier to write. So I don't know if you remember what it looked like last time, but we were dealing with buffered string readers and flushing buffered outputs so that we could get access to the output, and then comparing things on new line delimited so that we could figure out what was going on. But in this case, you'll notice reference to something that I've called mock I/O, which is right here. So mock I/O is not drawn in this. It's not drawn anywhere in this diagram, but it is another implementation of the user I/O interface. Except for what this thing does is it has a memory. It remembers everything it was given to echo back as user inputs, and it remembers everything that it was told to print so that we could get it back out and test it. And so our untestable test now is able to give a slightly more natural looking list of parameters rather than a new line delimited list of parameters. And this is the in-order playback that we're mocking our user performing. We still have to inject the I/O implementation using this sort of pseudo-singleton pattern. We haven't gotten rid of that yet. But now I'm able to call main, passing in a command. And when this method is done when this method is done running, I can revisit my mock object, pull back its generated outputs, which were remembered from the test that just ran through it. And now I can assert that the username, that what was printed out was a prompt for a username, a prompt for a password, a prompt to remember whether or not, or prompt for whether or not I want that password remembered, and then again, this message, because the only thing we can get Bitbucket to tell us is that it's not going to talk to us. And so our test, not only can we get it slightly more elegant, so we can get it slightly more elegantly written, but we can't write any more tests yet. We can just write the test that we did have a little bit better. And the key points that I wanted to call out here, again, are that we don't have to settle for the interfaces that exist. We can create our own, using implementations that do exist to implement them in a very easy way. We can create mock implementations of those interfaces so that we can totally control the behavior. Again, sort of getting closer to this pattern of unit test design and development. And I think those are the main points that I wanted to make here. So the two things that we don't like are so the thing that we don't like, that we're going to fix in this next round of edits, is that we've got this pseudo singleton pattern working, and technically this class, the untestable class, still has a line drawn between it and the console IO, meaning that it is still coupled to the implementation of console IO. So if console IO were anything more sophisticated that needed to be initialized in a more sophisticated way than just calling an empty argument constructor, Untestable would be in the business of trying to figure out exactly how to do that. If it were something that needed a proxy to connect to the internet to do something, Untestable is in the business now of understanding what the right proxy is to use, how to set up that proxy, how to set up connection timeouts, and that is very much not what we want the sort of hub of our application to be about. We'd rather relegate that to something that looks a lot more like configuration. And so we get to this checkout here. So, always do that.
Before you go on,
Yeah,
you wrote your own mock object.
yes.
So when do you make a determination to use one of the mocking libraries?
We make that determination in Fluent Test with Makito, I think is when we make that determination.
Okay.
So when you hit tag in your professional careers, when you get to item number 6, that's when you know to start using Makito. I'm walking us to that point, I suppose. Okay. Maybe not fast enough. So I'm going to check out this, where, as you can tell from the commit message, we're going to attempt to solve. We're going to attempt to solve this coupling problem using the concept of dependency injection. In this case, I've chosen the Spring library. But the focus of this talk and this sort of presentation is not on Spring. It's on the importance of introducing these kinds of concepts into your code base. So there are others. I think Plexus is maybe another one I can think of. And I imagine, I don't know, probably tens of others, dependency injection frameworks. But this was the one I was most familiar with. So for the purpose of putting together a quick demo, this seemed most attractive. So we use dependency injection via Spring to further decouple the application from the user IO component. So let's see about how we do that. So if we had to now redraw the design diagram, we've done a few things. One is that we've introduced this thing called Bitbucket Client App. And this is separate than from what Untestable was. And in somewhere in here, we talk about why we're doing this. So I'm sorry, let me talk about these bottom boxes as well. So we also introduced something called the DI framework, which in parentheses I might have written Spring. But this dependency injection framework is driven by a configuration file, which we can go and look at in a second. But what this dependency injection framework is responsible for doing is it's the thing now that creates the console IO, which means that I don't have a creates line going from either Untestable or Bitbucket Client App down to my console IO. And if I were to go look at the code for this Bitbucket Client App, nowhere anywhere in this code do I see any mention of the implementation class console IO. It's also the dependency injection framework that's responsible for creating the Bitbucket Client App and injecting into it its dependency, which is a real version of a console IO object. And this means that the untestable app is now relegated to the role of a simple bootstrapper. So all Untestable is going to do now is tell the dependency injection framework where its configuration is, and then ask the dependency injection framework to get back an instance of the Bitbucket client app. And then the Bitbucket client app takes over the role that untestable.java used to hold. So let's peek into that a little bit. Untestable. So you can see that our code base is starting to grow here. I've got my Spring configuration, which if you guys are familiar with Spring, assuming generally familiar, anything that we want the container to the dependency injection framework to manage for us, we can mark. We get the opportunity to create here. We mark that method as a bean. Now the dependency injection framework knows where to go to get instances of this thing that we need. And we can use this. So we've got 2 beans now. We've got the Bitbucket client app, which implements a new interface that we've introduced called arg-driven application, which is an app that runs given a context described by a list of arguments. So it's sort of one step removed while still sort of looking like a static main method. And all it does is have a run method that runs the application. And then our Bitbucket client app, our untestable, like I said, is relegated to the role of bootstrapper. So all it does is it visits Spring's annotation config application context and says, here's your configuration file. Give me back an arg-driven application, and I'm going to run it past delegating to it the arguments that run the app. We're still using this singleton pattern here, and I haven't thought of a way to actually get rid of it, because now, how do you bootstrap the bootstrapper is sort of the question, and I don't know that there's a good answer for that. But I'm not saying that this pattern is never appropriate. I think it's appropriate when deployed in the right way. So this is going to be, I think this is going to be it for what we end up doing to untestable. We've relegated it to the role of a simple bootstrapper, responsible for visiting our dependency injection container and just grabbing back all, the bean that it needs in order to run the functionality. The Bitbucket client app now looks a lot more like the untestable thing did earlier. It still has all the same problems in it that it might have had before, with the exception that we're able to get rid of the line of code that says, if the IO is null, give me a new console IO. Here, there is no mention anywhere in this class of console IO. So I would argue that we are successfully sort of decoupled from any implementation of the IO dependency from inside the Bitbucket client app. Otherwise, it looks exactly the same. So if we stopped here, it would be a lot of work to get rid of like 3 lines of code, but we're not going to stop here. So let's see, what are we going to do? So I think it was at this point that I decided it makes sense to attempt to catch up the rest of our application's design to some of the patterns that we've come across here. And so what we're going to do is apply the pattern that we applied here the 2 other places inside the application. We're going to create an interface called Credential Persistence, which is responsible for managing the credentials. And we're going to create something called Bitbucket Client, which is an interface responsible for interacting with the Bitbucket service. We will then introduce implementations of each one of these things that look very similar to what some of that implementation-specific code looks like inside of our Bitbucket client app. And then these are the only components that are sort of tightly coupled to these very hard-to-test dependencies. But everything else is removed from the list of really coupled dependencies of this Bitbucket client app. So let me check that out. Yeah, sure.
Maybe I missed it.
Yeah.
But I understood when you introduced Spring how the old untestable app is using it for
Yeah.
injection. But I didn't remember seeing what the test was like with that.
Oh, I'm sorry. Yeah, let's go back and look at those tests. I don't think I highlighted it here simply because the tests, in all the work that we just did, the tests haven't changed that much.
Okay.
But let's see what the untestable app looks like. Sorry. So the untestable test, as I said, the untestable is sort of relegated to the role of bootstrapper. Now, we can't get away from the fact that the first line of code that any Java application is going to have executed is the first line of the static void main method inside of this class. There needs to be a single point of entry for every Java application, and this is it. So normally you wouldn't create an entire application or system using static methods and static classes. But in the case of the very top of your application, if you're talking about kind of a native Java application, you're not going to be able to get away from that.
Sure.
And so in this scenario, we did have to do, I suppose, one sort of semi-tricky thing. You'll note that the untestable application does need a configuration file in order to get Spring to do the right thing and return the bean that it's after. And so we introduced this arg-driven app as the interface that this thing is coupled to. And what we've done here is said, we're going to create something called a mock application that implements this arg-driven application interface. We're also going to create a test configuration that is only used and is specific to this unit test. And we're going to tell our test configuration that when the dependency injection framework asks it for an arg-driven application, we're going to return our mock application. Again, so that we can solve the problem of mocking out all the dependencies of the component that is under test. So in this case, we've got a static method that relies on Spring to give it a bean back. Unfortunately, I believe this Spring method is, I think this is a, well, maybe we could have, this Spring class is created in line. An instance of it is created in line right here. Maybe I could have designed it a little bit differently so that it wasn't, but in this version of the implementation, we have to give Spring, because this is the real Spring framework, a real configuration for it to drive off of. And so in this case, we've given it a configuration that we call the test config that when asked for an arg-driven application is going to return a mock arg-driven application bean. At which point it calls app.run, but this mock application, all it does is just remember the args that it was passed, so that in our untestable test, we set, using sort of the pattern we had seen before, we set the configuration to our test config class. We call the argument, the main method passing in anything, because all we have to do at this level is just validate that this bootstrapper is doing what we said it would, which was take whatever it's given and give it to the thing underneath it. So in this case, we give it the word whatever, and then we assert that we get the array with the word whatever right back. And that really wraps up all you would need to do, I think, in this bootstrapping version of Untestable. The Bitbucket client app is where the meat of the application continues to live. And as I said, we haven't really addressed the ability to run a full suite of tests against all the different aspects of this application. So the Bitbucket client app test continues to just be the same two tests we've always had. Written essentially the same way they've always been written, with the exception that it's using the word Bitbucket client app where it used to use the word untestable. But we can compare these two guys. This is what it used to look like. Really, it's just more or less a search and replace for everywhere there was Bitbucket client app. We've now added untestable. But like I said, we haven't gotten to the point yet of introducing more sophisticated techniques for getting this to a better spot.
So another comment or
Sure.
question. Test-driven development.
Yes.
So I know you're presenting this in a logical fashion.
Yep.
When you were actually doing it, or would you put TBD in there?
Yes, I think I would. I think this is going to culminate in something that looks a lot more like test-driven development than where we started. There are aspects of this that I don't think. The one thing that I would have done differently, if I was going to do test-driven development the way I understand it's talked about, is I probably would have led with my full set of requirements about the way that I expect my application to behave. And I'd put @ignore over all the tests that wouldn't actually be able to run and validate those requirements. That's more or less sort of like a procedural issue, I think. But you know, even if I didn't write it that way, that was sort of what was in my head as we're proceeding through it. We're sort of walking up to the point of concluding that maybe a better way of starting this application, the development of this application, was to document and get an understanding of the requirements that are driving its development. Let's see. I forgot what branch. So I'm on API. Okay, so I think we were about to get to here. So here we're going to catch up with some of the patterns that we introduced lower down. And we're going to do that by using essentially just rubber stamping the pattern across the stack to say, well, if we had something that was console I/O that gave us access to the file system, now we're going to have something that gives us access to the credentials and something else that gives us access to Bitbucket. So let me check that out. So here's the catching up. Okay, so all we're going to do here is catch up the other components to the design paradigm introduced in the previous commits. Using, again, the concepts of programming to an interface, and dependency injection to separate the application from the concerns of interacting with these lower level things. And so again, here we go, just refresh. So the code base is starting to get a little bit larger as we introduce the need for more decoupling and some of the other things we need in order to get to a place where we are very testable. So we've got console I/O, which we've always had. I'm sorry, user I/O, which we've always had. We introduced this notion of credential persistence and a credential POJO, which just holds a username and a password. And we present back to the user of this interface a simple method for persisting credentials and a simple method for retrieving them. The details of exactly how that's persisted are entirely not mentioned anywhere in here. This gives us the opportunity to switch this out for something that persisted to a database if we wanted to, something that persisted it to, I don't know, come up with anything you could think of, and we could write an adapter that would do it. In this instance, though, we wrote the file-based credential persistence class, which does all the things that we used to cringe about doing inside the application itself. So here's where we have access to a buffered writer that has access to a file on the file system. Here we've determined what our format is going to be for persisting a credential. It's just a username, new line, password. So we had to come up with a format for how we were going to persist it. And then the format is, again, sort of observed in the reverse. We read the first line as the password and the second line, or the first line is the username and the second line is the password. But this is all hidden behind the interface. Similarly, we've introduced something called the Bitbucket client. And the Bitbucket client is a simpler way of getting a user and getting a user repository. And it also encapsulates its response in something called the Bitbucket response, which is nothing more than a status code, a reason, and the JSON response body. So we could have gone, if we wanted to get even more decoupled, I suppose, from something that was an HTTP-based service, then we would have need to introduce concepts that were much more agnostic of the underlying implementation. I didn't go to that effort here because I didn't have the time, but or I didn't invent the requirement that said I needed to. But if we needed to communicate with some other implementation of a Bitbucket service that wasn't HTTP-based, it would become inappropriate for us to create a Bitbucket response that had something like a status code in it or a reason. And then JSON, even though it's not built specifically for REST-based services, is pretty REST associated. So if we started to move to something like a SOAP-based service, we'd now be in the business of trying to convert an XML object to a JSON object, and we'd have to pick a standard way of doing that. And again, this all kind of boils down to the difficulty of designing an interface and how forward-thinking you have to be when you put one together. There's an art, definitely more of an art than a science, to designing something that gives you the level of decoupling that you need without making you go through hoops to abstract away concerns that are never going to be something that you have to abstract yourself from. It's probably reasonable to assume that for a few years anyway, maybe, that we might continue to interact with something that looks like an HTTP service for Bitbucket information. But if at any point that becomes not true, then this interface starts to look a little bit less appropriate. And the users of it would complain that, oh, what do you mean I have to I have to map a HTTP response code to whatever it is underneath that's actually responding. Yeah. So importantly, though, now that we've mocked out all these other concerns, meaning this stripe, and this stripe, we can finally write unit tests that cover the gamut of all of our use cases. So I've gone from having 2 unit tests, to now I've got 7 of them. And this covers, as best as I could think anyway, the requirements and the behaviors of our application. We should probably check here and make sure that, let's see if I've managed to avoid doing this. Install. Please work. I think it worked. All right. Yay. Okay. I haven't been lying. So we now have 9 tests across 2 different test suites, test components, that validate really the full behavior of our entire system. So we've gone from, and all the while, I should note that target, let's check to see if we still have a working application, I guess would be the next question. That's actually a bug, I fixed it next time. I didn't check for somebody not entering it. There we go. So it's still, my credentials file is still on my file system from the last time I ran this. And I've gone to all this work, and I haven't even introduced any features yet. So some skeptics might look at this and go, well, what are you spending all this time for? But this is the classic question that your manager asks you anyway, right? So it's good to have a good response to that. You say, well, I was making the system more testable. And then you got to convince them that you can make money off of more testable. I think that you probably can over the long run. This should work too. And if I remove testable, I should continue to be prompted for a password. And, okay, it's not going to echo it back up. And that one remembered. And the whole flow continues to work. So we've done a lot of work, and we haven't gotten any new functionality, but that's sort of the point of the talk anyway, so too bad. But let's look at now what this test looks like. And now we can start to get a little bit more critical about how expressive we can and should be in one of these tests. So as Paul pointed out, the question was, when would you consider bringing in a framework like Mockito? The reason that Mockito exists is because if it didn't, you'd have to write unit tests that look like this, which looks like inline anonymous classes that define mock, essentially, implementations of interfaces that you need mocked out. Now, in my credential, one of the problems with, not one of the problems, one of the realities of an anonymous inline class is that you're defining a full implementation of whatever the interface is that you're specifying. So as this implementation grows, like if we decided to introduce more functionality to any of these interfaces, I'd have more and more methods with nothing in them. Because the focus of this particular test doesn't have to do anything with persisting, but apparently has something to do with retrieving. So it's not important to me what happens here, but it's important to me about what happens here. The place where I think we are most susceptible to this problem is in the Bitbucket client. So if you go visit the Bitbucket documentation for their set of REST services, they've got like 100 of them. If we wanted to evolve this system to get to the point where we wanted to support a command line version of calling every one of those 100 services, this unit test would grow by probably 4 lines per service that you wanted to implement. And now you're really running up against the headache of maintainable software over a longer time horizon. As what seems like a reasonable choice to make now becomes a huge headache a year from now when you have to support 20 instead of 2 calls to the Bitbucket client service. And the other thing that Mockito introduced, the other thing that we've had to do before I get there, is that some of these, I need these mock classes to be stateful, meaning I need them to remember what they did so that I can check it later and make sure that it was doing the right thing. Which is a little bit harder to do, although not impossible, but a little bit harder to do with anonymous inner classes, because you can only pass final variables into anonymous inner classes that you can then access outside the closure. which means that you can't like do anything useful with something like a Boolean, or even like a capital Boolean. Somewhere in here, I think I was fiddling around with it. You actually have to like, actually let me show you. There's some really weird thing that we had to do in here, or at least I remember writing it. Let's see this thing here. There. So within an anonymous inner class, you can only access final variables. So you have to do this funny hack to actually get a Boolean into a Credential Persistence anonymous class. So here I create a list, and inside this list I put a capital Boolean object at the very first location in the list, so that I can just access it later and flip it to true, so that I can access it later and validate that the first Boolean in the was called list is set to the right value. So you're really like struggling to write something that looks like sane, readable code without a framework like Mockito, JMock, or I don't know, any of the others that might exist. I think that's the main gripe I have with this solution, and it's the focus of the next commit. So let's go. Okay, so this one is about Fluent Test with Mockito. So in this section, the focus, or in this commit, basically, the focus is purely on writing a better unit test. So there's no new diagram here about the system design because we're not going to touch it. All we're going to do is see if we can write a unit test that is much more readable, expressive, and still correct using a library and the tools that it provides. So Mockito provides two really key pieces of functionality. One is the ability to dynamically create mock classes and control their behavior. This is almost always done under the covers using the CGLib library, if you guys are familiar with that. And most of the good ones anyway offer a carefully designed Fluent interface aimed at getting as close as possible to test code that reads in English like the requirements they are testing. So what you'll see in this commit is that we can write things that look much more like English, which is always good if you can get it. So let's see. So let's see, we're bringing in the mocking framework. While I was at it, I decided to go ahead and essentially document in a test-driven sort of development way. The way I would advocate if you're starting with test-driven development from the outset is to document very clearly what the preconditions are, what the thing is that you're testing, and then what all the post-conditions should be. So let's go look at what just happened. So we can look at one of our tests here, and I think it's most interesting to compare this to what it used to look like, which would be... So this test on the left, these tests, test one here and test one there, are equivalent. They test exactly the same thing. But they are able to do it in a much more natural way. The requirement isn't any different. It's tested when JUser command is given a bad password and error is appropriately written to the output. But what we're able to do is essentially write every precondition as an English sentence. So when there are no stored credentials, and when the username is valid, and when the password is invalid, and when the user doesn't want to receive the credentials or doesn't want to have the credentials remembered, and when the Bitbucket get user service responds with unauthorized, and the app is run with the JUser command, the app should collect the username, the password, it should collect whether or not that we want it remembered. It should never persist any credentials, and it should verify that we displayed that there was a problem calling the service. That's probably easier to read here, sorry. And so we're capturing here the two really sort of important aspects of using something like Mockito. One is that there's some really handy mechanisms for automatically setting up and injecting your component under test with the mock implementations that it requires. You can kind of just do it in one line and a few annotations. And then the ability to write highly readable tests that read almost like requirements is greatly enhanced. And so we haven't introduced any more tests. We're still running the same ones we always have. But we have introduced Mockito. So let's see. I think we said we had 9 tests last time. Oh, maybe I added one. I added a few. All right, so I added a few. But the I'm sorry. We didn't check. I've added a few more tests because I haven't run these since we also mocked out our underlying dependency. So I was able to add a few more tests when I did that. But again, the point is that we actually haven't added any more functionality, so this should still work. But we've added tests that if you were to revisit this over a longer period of time and were curious about like what the requirements of the system were, scanning quickly through the set of unit tests should give you a pretty strong idea of what the expected behavior of this application is. And then I think this is just remaking the same point I was just making. Okay, so yes?
What is that mocking tissue?
Okay, so there's a lot of, have you used any mocking framework? Okay, so I don't know what the other ones look like, so I was going to help you by drawing an analogy, but I don't think that's going to help in this scenario. So what we're saying up here is that this is our test suite, and then every test suite is ideally focused on testing exactly one component. So you would expect at the header almost of any one test suite to be able to add something that looks like inject mocks on the top of the declaration of the type that you want to test. And so what this is telling Mockito essentially is that this is my component under test. This is the thing I'm interested in testing. Then after that, you list n number of mocked dependencies, which is to say that this application, in order to work the way that it's supposed to, relies on credential persistence, relies on user I/O, and relies on Bitbucket client. And when I create an at before, like a setup function in here, I tag it with at before, which means it's going to get run before every single test. So it'll get, in this case, I've got 8 tests. So this is going to get called 8 times, once before every one of these tests is actually run by JUnit. And what I'm doing here is I'm going to Mockito, the framework, and saying init mocks on myself. And so what Mockito is going to do is, I'm assuming, reflect on this class and say, give me all the things that are marked at inject mocks, give me all the things that are marked at mock, and tie them all together for me. So that by the time my test actually runs, I'm guaranteed that every one of these things is equal to an instance. And if we, actually be interesting to do this, let's see if we can do it really quick. Bitbucket client test. Let's see if we can make it work. There we go. So nowhere in here do I say new anything, right? So just looking at this, you might not expect there to be an actual instance. You might think all these things were null. But after having annotated it this way and initialized myself this way, by the time I'm ready to run this test, if I look at what this mock credential persistence actually is, you can see that it's a credential persistence class, essentially a proxy class, built by Mockito using cglib. So it is a class in the JVM. There's a definition of it. There's some bytecode floating around in memory somewhere that implements this class. But by default, this class is, and by default, there is a default implementation of all the methods in this class. So any method that returns an object has a default implementation provided by Mockito that returns null. And any method that returns void has a default implementation by Mockito that doesn't do anything. It just quietly returns. But what we get the opportunity to do is to use what I was referring to as Mockito's Fluent interfaces or Fluent methods to begin to define what we'd like the behavior of the retrieve method to be for this mock client. So if this line were commented out, the next time this mockcp.retrieve is called, it's actually going to return null. So if I were to click through into my application instance, which is a real instance, here, we can see that it tries to retrieve credentials. So like I said, Mockito, if I don't tell it otherwise, is going to return null when this is called. So that when I do something like creds dot, somewhere I say creds dot something. No, I guess I don't. I pass these credentials. So first of all, the credentials are always going to be null, so I wouldn't be able to test the non-null use case. And then that, if I were to care about some of the properties inside these credentials, I get a null pointer exception. So yeah, so using this when function, I mean, it does what you might think it would do by reading this in English, right? When my mock credential persistence has its retrieve method called, then return null. When my mock IO instance has its collect method called with the argument username, then return tcbase, and so on. So in this way, I get to define all of the behavior that I want, meaning I have total control over this mock object, but I didn't have to actually go create an anonymous class that would do it for me, nor did I have to go create a real class that was cluttering up my test folder. Does that make sense? And then I'll continue with this. Let's finish.
So you need to set that up for the test.
Yeah. So this, anything that is in any test class that is in my, currently in my test folder has, would have a similar looking setup where the kind of the formula is you inject mocks on the thing you want to test, and then you mock out all the things that that thing depends on, and then you go on your merry way telling it how you want to behave for whatever the particular use case is. So this gets into sort of the more, I don't want to say esoteric, but the finer points of, I don't know, writing good unit tests and by the very nature of them, writing better or designing better software. So a unit test, sort of by the definition, is responsible for testing a unit. So if your units are really large, then your tests are going to be really large. If your units are really small, then your tests are going to be really small. Now that's not necessarily a good or bad thing, it's just the nature of what it is. But when we're shooting for maximum level of conciseness, I don't know what the better adverb for that would be, but when we're shooting for maximum level of conciseness, you'll get there by defining by defining smaller units of code. So things that have one role and one role only are usually a lot easier to write, usually have last a lot longer in terms of the lifetime of your system, because there's much less likely to be a requirement that does change that trickles back and affects a very small core component. And so you can kind of tell by reading through the requirements what some of these things look like. So here's a requirement from test 1. This is just the comments that I copied out of the test and wrote as a requirement. So test 1 says, when there are no stored credentials and when blah, 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 stuff about credentials, stuff about calling a service, when the app is run with the JUser command, the app should stuff about collecting credentials and then stuff about returning responses. Here's another one from test 2, right? You'll note that the words up here are exactly the same. And the same when you see like repeated code inside of a class or anywhere in your code, and you think, usually that's like a trigger that should go off. Like if this is literally the copy paste of another line of code somewhere, maybe there's an opportunity for me to write it once and share it and reuse it. The same holds true really for requirements. If you're looking through requirements and you see the same thing repeated over and over again, I would argue that there's an opportunity to pull something out of that and implement it as a rule or a pattern or a requirement that extends beyond the focus of a single use case and across the entire application, regardless of what the use case is. And so I wanted to highlight some of these as an argument for what I think can be factored out. And so here's another one from test 7. So when there are no stored credentials and blah, 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 blah. And so what you look through, this one is a little bit different. It's about when there's an unrecognized command that is passed, then we should display back to the user a message explaining that this command is not supported. And so when you look at these, what you kind of notice is that maybe there's at least two rules present in all of these use cases. One is that a user's request for a command should be routed to a specific command capable of handling that request. If no command exists to support the user's request, an error message should be displayed. Regardless of however many commands are further introduced into the system, I would argue that this is always going to hold true. Could a component be designed whose sole purpose was to solve this rule or this requirement and leave the rest of the system to be implemented by other components? I think that it can. There's another one here where commands requiring credentials should solicit them from the user. There's some more detail not specified here about exactly how we want to solicit commands from the user, but the general pattern of soliciting credentials from a user is going to be true and hold true regardless. I highlighted these two because I think they're somewhat interesting. This is sort of speaking to the ability to be able to share a workflow, or a flow, I guess. I'm going to call it later on a flow. And this is speaking to the ability of what I think is maybe a candidate for the visitor pattern, where we have some central component whose only role is to divvy out execution requests to the commands that can support them. And then later on, we'll have something that's responsible for managing shared workflows. Let's see. So in this first commit, we're going to define a smaller unit by again, introducing an interface. And this interface is, oops, it's improperly formatted, I apologize. But that from here forward is intended to be source code. So a command is something that interacts with a user to perform some useful activity and is identified by a simple string command name. So it looks like it needs to be able to answer the question, can you handle this command? It needs to be able to print its command name back out, or return its command name. And then when asked to, it needs to be able to run. And so what we're going to do is, as you can kind of see, the pattern is whenever you want to decouple something, it's usually time to introduce an interface if one doesn't exist. So we've introduced an interface that controls very explicitly what it is, or that exposes very explicitly the behavior that we're interested in. And then we tweak our design a little bit to accommodate this new pattern. So where the Bitbucket client app used to handle directly an instance of a GUser command, or I should say, handle directly the implementation of the GUser command and the implementation of the grepos command. Here we've abstracted that behind an interface called command. And now the Bitbucket client's app only responsibility is to aggregate commands and to route them to the appropriate command provider. So let me, I think this source code is interesting, so let's pull it back. And we should see that there's sort of a nice side effect on what we get to do with our unit tests after this as well. Because the same way we got to factor out a common concern from our use cases, we can factor out the code that implements that common concern from our tests. So let me check out. So this is about defining smaller units. So we're addressing some of the, as I said, we're addressing some of the redundancy in both the code and the unit test by changing the role of the Bitbucket client app from an Uber command executor to a more focused command router. I don't know if you guys refer to it as frequently in your company as we refer to it in ours, but there's this notion of the monolith, and nobody likes the monolith. But essentially, even though it's only 12 lines long, or however many lines long it is, the version of the Bitbucket client app that we had here was well on its way towards becoming a monolith. Every time a command was going to be introduced, we'd go introduce a new else statement that said, when this new command comes in, here's how to implement it. And that code was going to grow forever. When really all it's doing is a naive implementation of a router. So why not build a router that never has to change no matter how many commands are introduced? Or at least that's the argument for this change. So let's pull back. I think I just grabbed it, so let's pull back. So here's our new Bitbucket client app. Let's see what happened to it. So it used to do all this stuff, blah, 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 right? Now all it's doing is routing. So all it does is it still actually needs the user I/O because it does implement, the one command that it does implement is the not found command, basically. You pass it in nothing that it recognizes, and we've determined anyway that this router is responsible for echoing an error message back out to the user. But other than that, instead of requiring the Bitbucket client and the credential persistence mechanism so that it could implement the details of the command, now it simply requires a list of commands. And since every command can answer the question, am I able to handle this, then all we have to do is loop through the commands, ask if it's possible for that command to be handled, and then run it if it is. There's actually no argument to even pass through to it because the only role that this argument plays is identifying the command. Once we've identified it, we know it's safe to run without any further context. The only thing that's left to do is to say if it's not handled, spit out that this is an unrecognized command. And then this is actually a bug I fixed that we saw a second ago when I was running it, which is I didn't appropriately handle what happens when nobody passes it, when there's no command passed in. So while I was at it, I fixed that. And so the unit test for this is now quite a bit simpler because it's doing not nearly as much stuff as it used to. So there used to be 8 things that we had to check in here. Now there's only 3. An unrecognized command should display an error to the user. An unrecognized command should, oh, this is, sorry, that's copy paste error. One of these is, you can tell I put this together, just finished putting this together this afternoon. These 2 tests are doing something different. I don't know what, but they're doing something different. This last one then is, yeah, so this is no command provided. We expect no command provided to be echoed back out. So this is the pattern that we've implemented. Oh, the other benefit of this is that we've now we've relegated the implementation of the command to classes called the name of the command, basically, which from a readability standpoint is quite a bit better, I think. And the only thing that this does is the logic that is needed in order to execute that thing. So here we've got the guser command logic for executing guser. Here we've got the guser repos logic for getting the user's repositories. And now we get to divide our tests into 2 different test classes that are focused just on testing the logic of that command. So we've got new tests in here. And here's where you see the same pattern introduced of injecting mocks into the thing that you're testing and providing all the mock classes that make it work. And here, again, we have our very fluent requirements written in Mockito's language. And the difference here is that we used to have to, this line, when it existed in Bitbucket client app test, actually had to provide the command that was being run. Here we're just saying command run yourself because we already know what the command is that we're testing. So through this design change, we've been able to further sort of segregate concerns from each other. We've created a router that should hopefully live for a very long time, regardless of how many commands are introduced. The implementation of the command is relegated to a class called the name of the command, which is extremely easy to identify and read and understand. And the implementation of the command's run method is focused not on finding the right command to delegate it to, but focused purely on creating the command. I'm sorry, executing the logic of the command. Those are the main highlights from this, which brings us to the culmination of all of this, I think. Let me see if there's anything else. Test 1, test 2. Okay. So the other, now we want to tackle that other rule that we identified. So this is, I think this is kind of cool. You guys will be the judge of that. So to recap, we've noted that the repeated requirement of credential collection and management, or we've noted that there seems to be a repeated requirement of credential collection and management. Given that it's sprayed across almost all of our unit tests, it's pretty hard to miss. From this, we have concluded the existence of the following sort of overarching rule. Commands requiring credentials should solicit them from the user. The details of exactly how to collect and manage credentials are also detailed throughout the test. The goal here will be to define an approach for reusing an implementation of this rule across all commands that might need credentials. So here, we introduce the concept of a flow. So what is a flow? A flow is a reusable interaction that displays and collects information. We're using a generic type here so that the kind of information that is collected and returned to the user of the flow is definable in a more, I don't know, in a better way, I suppose. And it's only got one method. It runs the flow and returns an object encapsulating the data collected. And here's the portion of the implementation from simple, actually before I get in here, let's just check it out. Okay, so maybe try to figure out what the best ways to talk about this. Yeah, let's maybe start with this thing here. Unfortunately, it doesn't all fit. My decision to use ASCII artists by remaining it. I don't know if this is all going to fit in here either. Come on. too big. All right, where else was it? Here? Yes, okay, that's right. That's why I put it there, because it didn't fit anywhere else. Okay, so we've made it to the piece de resistance, as it were. So what have we done? We've introduced something called a flow. Do I get a mouse? You'll have to bear with me. There we go. Okay, so we introduced something called a flow as an interface. We provide the one and only implementation of that interface called the simple credentials collection flow, which uses all the same. Actually, I don't think I drew the line. I should have, but I didn't draw the line. There's a line here that says the simple credentials collection flow requires user I/O because it's responsible for interacting with the user to collect credentials, and it requires credential persistence. But it does not require Bitbucket client because it's not interacting with the Bitbucket service. The flow is marked as in the console config as a bean so that it's available for injection into other things. And then inside JUser command and JUser repos command, you're supposed to be able to follow this shared line here and see that this thing now gets a flow. But it doesn't get simple client credentials flow, it just gets a flow that can rely on to collect credentials. Yeah, everything else is about the same. Okay. Okay, so I got the code. So hopefully with that context, it's going to make sense as I jump around a little bit. Apologize if it's flying by too quickly. So here's our flow. Here's our simple client credentials flow, which implements a flow, but specifies that it's responsible for collecting credentials. It requires user I/O and it requires credential persistence, and then it runs. So, and it runs this is exactly this like verbatim code, or at least this chunk of essentially business logic, is verbatim from everywhere that's ever existed in the system, but it's traveled. It's actually come quite a long way. I think we should give it a hand for that. It used to live in. Yeah, there you go, right? It used to live in there, then it's made its way into there, then it's made its way into there and into there, and finally it's made its way into its own thing over here. But the logic of it has not changed. The console config, I actually had to Google this to see if it was even possible because I hadn't tried to do it in Spring before. But in Spring 4, they have better support for dealing with injected generic types than they've had before. Which means that inside credentials, like in Spring 3, I would have actually had to write something that would have invalidated the whole idea. I would have had to write here simple client credentials flow, which I don't want to do if I want to begin to introduce the notion that there might be different ways of collecting credentials. We either want to word it slightly differently, we want to collect credentials by sending you an email and having you email us your password back. Doesn't sound good, but maybe you want to do that. But the point is that you don't have to declare anything about the implementation of the flow other than it has to give you back credentials, which is beautiful because we don't care about how it's done as long as it's done. So this is in JUser command. This is in JUser repos command. And if we compare this, let's see, it's auto-wired, so we get it for free. If we compare this to what it used to look like, the only difference is that we've taken out credential persistence, replaced it with a flow that's responsible and capable of collecting credentials, and taken all this logic out of it and replaced it with a simple call to, hey, this thing that knows how to get credentials, run yourself and give me the credentials back. At which point we can go about passing those credentials onto the command, the get user repos command, and everything is sort of beautifully handled for us. The other really important point, and the whole really, again, this is all sort of looking at this through the lens of testing, or better testing. One of the motivations for this, or one of the ways that we first recognized this, was by reading through the requirements and identifying this pattern of this credentials thing looks like a common concern across a lot of different commands. So we go into the JUser command test, which used to look like this. So this test used to have to say in explicit detail how to collect credentials. But what we were really actually interested in testing was just that the damn command worked, right? Not that the credentials were collected in the right way, in the right order, that passwords were hidden, that things weren't persisted when we told them not to be. So all of that gets simplified into one line now that says when there are credentials. However they were defined, doesn't matter, as long as they exist. That's good enough for me to be able to continue on with the details and the intricacies of testing this command. And we get to do this everywhere. Not only do we get to get rid of the precondition setup, we get to get rid of the post-condition validation. So we don't care anymore about were the credentials collected in the right way. All we have to say is verify that the right thing was echoed back out to the user, regardless of how credentials were collected. The other thing that we get to do is focus the details of the testing of how we're collecting credentials in exactly one spot in a non-repetitive way that doesn't have anything to do with calling services, but is focused primarily or only on how the password was collected and whether or not it was persisted appropriately. And let's see, is there any other point? I feel I should go like, damn it, we did it. But I can't think of a good point to smack my fist on. Yeah, maybe that's about it. So I guess I'll end with a whimper. Oh, I'm sorry, the console config. And we haven't looked at the console config in a while. But you can see here that my console configuration is the declarative way, basically, of gluing together all my different components. And the glue, or the glue and the wiring, is defined only in this one class. So I've been able to factor out all my dependencies. I still have to declare them somewhere, but I can do it in a console configuration file. Now, if I wanted to, I was actually going to try to do this, but I didn't have enough time. I was considering like implementing a Twitter I/O or something as like another I/O, where I could interact with this application by like tweeting about it or something on my phone. I don't know, it's kind of esoteric. But the idea would be that I could get exactly that behavior by defining Twitter config if I wanted to, defining all the appropriate mechanisms for persistence and communicating with the user, executing a bucket command, etc. And all I'm doing really is just playing around with the building blocks that I've already got, wiring them together in a way that is sensible and actually produces a functioning application. And to prove that point, that it is still a functioning application, I just want to run one more time. So I should have a lot more tests spread across. Like I said, I don't have a lot more. So I don't have a lot more tests, but now they are organized into a lot more test files, where each file is focused just on the requirement that it is testing, and that by the end of it, I can still run that, and it still works. So we did a lot of work to get no new features, but I would argue that we're in a better position to introduce any new, a number of new features going forward. And to come back around to sort of the conclusion that I had initially is that you can tell a lot about a system simply by looking at the unit tests. If all you gave me was the unit tests, I could probably tell you a little bit about how it was designed and what could we do to improve what could be done to get it into a better spot. So if the tests are redundant, hard to follow, and lacking any real organization, there's more than a good chance that the system itself suffers from the same problems. If, on the other hand, the tests are concise and focus on one very specific aspect of the system at a time, this is almost a guarantee that the system is implemented using sound software design principles. The two really go hand in hand. And hopefully this project and this talk, and myself, have convinced you of that. But that's it. That's all I got. So any questions?
What do you use to make your diagram, SQR diagram?
Oh, yeah, that was kind of cool, wasn't it? It's not easy to use. It's definitely harder than doing it in a different language. But I don't know. It's somewhere in here. Oh, here it is. Untestable. There. So I used it up here. It's kind of tricky. It doesn't work exactly like you'd want it to, but it's a lot easier than trying to do it.
So you bring squares and stuff?
Yeah, you can draw squares and connect squares with lines and change text. You can't actually move a box, though. So once you put the box down, you better be confident that that's where you want.
So more related to what you were presenting.
Sure.
What are your thoughts on testing? Like I noticed you did test like console.io and the file-based
Right.
processing and stuff.
Yeah, so
Those will be integration tests, but
Yeah, we haven't talked a lot about like what's the philosophy behind integration testing. I'll get to that point in a second. Because there are ways that I can break this that the unit test would not catch. For instance, I guess I won't get to it in a second, I'll say it right now. If I were to delete, like if I were to go into, and this actually happened while I was putting this together. If I forget to annotate something with auto-wired, my unit tests are going to continue to work probably. Because I'm not relying on auto-wired to inject my dependency. But if I were to run this in an integration way, I'll get a null pointer exception the second that somebody tries to access this list. So that speaks to the importance of unit tests. My thoughts around testing some of these lower level things. I tried really hard to design interfaces where the implementations of those interfaces were devoid of any logic. It was just use this thing that already does the thing that I wanted to do and do it, right? So for console I/O, I think I was able to achieve that. Literally like one-line calls to lower level system functions that read and write things to the command line. If this were my team and they were building this project and they said, do we need to write a unit test for this thing? I'd say no, I don't think you do. If this were, however, here, I didn't write a unit test for this, but I actually have some logic here. I'm translating a response from one format to another. It's probably valid to say that we want that translated. I'm also catching one type of exception and translating it into another. That's essentially a business rule. I could, again, you kind of just recursively apply the pattern and say, okay, well then this thing needs an interface whose literally only implementation is to do that. And then the thing above it is responsible for translating it, interpreting it. And then I get to appropriately test that the translation is successful and done the way that it should be. And then I can test that this is being translated the way that it should be. But when I go about doing these things, if I get to the point where we've been able to successfully reduce something down to its essence, I tend to not feel the need to test it any further than that. All right, cool.
One more?
Oh, yeah.
I don't mind, it's not really a question, but when you first started and you showed your initial simplistic box diagram, it's like, oh, simple. And then the complex one, it looked complex. I mean,
It does.
there's enough there that it's kind of like, I don't know, dude. But really, once you walk through the approaches you're taking, it's not that complicated. I mean, there's a lot more code. Like we saw the project grow as we went along.
Yep.
A lot more pieces of code, but they all became real small, real focused. And once you know those patterns you talked about, it's easy to think about that model.
Yeah.
It's not that scary of a picture, really,
Right.
when you first look at it.
Yeah.
It's interesting. I just found that kind of fascinating.
Yeah, that always strikes me too about thinking about design this way. You know, there's always the trade-off of complexity versus elegance versus performance versus all these other things. There is really no right answer. For what started out as a 10-line command line application, this might have even been totally overkill. But the point was to kind of demonstrate that. Certainly if you recognize the patterns, then they kind of jump out at you when you look at the code. Following naming conventions and the way that you name some of your classes and organize them also really helps with understanding. And certainly having a unit test that almost read like the English they're testing is important as well.
Cool.
Cool, thank you.
Okay, thanks very much.
Thank you.
Okay, thank you all, and thank you again, Tristan,
Sure.
and having Intuit help us with the pizza. And of course, a very good presentation. And would you deal with me if you sent me a PDF or something of the slides and the source
Oh,
code?
yeah. So the source code, if anybody's interested, I'd actually, if you wouldn't mind, can you send it out to all these guys?
Yes, I can.
Okay.
Yeah, just
So the source code is all up on Bitbucket in a public repository. So it's tcbake/untestable on Bitbucket. That's where all this is, and then I can send the slides as well.
very good.
But there's only 4 slides. So.
Yeah, that's perfect. That's those diagrams.
Yeah.
Okay, thank you all. If we can clean up, and we'll see you all next month. Have a good night.
Thank you.